you probably learned that the sun is in space. You also probably learned that light travels in straight lines. So if the sun is in space and light travels in straight lines, then why isn't Earth's surface lit up all around? Why doesn't the light from the sun hit the ground over there or the astronauts on the International Space Station? Or, if I were to take this rock off of Earth and throw it into space, well, for an answer, turn off all of our lights here in the studio and try to imagine ourselves as a photon of light leaving the sun. It's hot and bright, and there are trillions of photons around us, bouncing off of each other and making it hard to think. But we have a mission to complete. We must travel to Earth and find out whether there's life there. Intelligent life that might be able to answer some of the great mysteries of the universe. Like what happened to the antimatter that should have been created in the Big Bang but wasn't. But before we get to Earth, we have to get through space, which is really, really dark. It's so dark in space that when I turn off the lights in the studio, it's about as bright as it is outside looking at the stars from Earth's surface. And that's because most of the light coming from those stars isn't actually visible light. They're emitting huge amounts of energy. Our eyes just can't see that wavelength of light. So we see stars as just points of light. That's one reason why you don't see light in space. It's because most of the light out there isn't visible light. But that doesn't explain why Earth's surface is lit up. After all, we know that Earth doesn't emit any light of its own. We can see that there's something called albedo, which is basically how reflective a surface is. If you were to take a perfectly white and a perfectly black piece of paper and them on the ground next to each other, you would find that after a minute or so, the white piece of paper would be noticeably brighter than the black one. That's because the white paper was reflecting more of the light that hit it. Earth has an albedo of about 30%, which means that, on average, about 30% of the light that hits it gets reflected back into space. The rest is absorbed and re-emitted as heat. Now, most of Earth's surface is made up of water, which has an albedo of about 6 to 7%. Land has an albedo of about 12%, but clouds can have an albedo of 80% or more. That's why when you see clouds in the sky, they re-reflecting so much of the little bit of light that managed to make it all the way through the atmosphere that they look bright. And that's why you don't see light in space. It's S, because the surfaces that are emitting the light we can see are really good at absorbing the light. They're getting and not very good at reflecting it. But that doesn't explain why the ground under our feet is lit up and not the ground over there. Well, that's because we're getting light from the side of the Earth that faces the sun. The ground over there is in Earth's shadow, and shadows don't glow. As for why your rock wouldn't glow if you threw it into space, light is an electromagnetic wave. It needs something to wiggle around in order to exist. There's no air in space, so there's nothing for the light waves to wiggle, and therefore no light. So, it's just really, really dark. But that doesn't mean there aren't other kinds of light out there. If you had eyes that could see infrared, you'd see all sorts of things you can't see with your normal eyes. You'd see heat signatures of objects around you. You'd see the dust clouds in space where stars are born. And you'd see me wearing my favorite hat.